start, and then I'll pass the introductions to our city staff first. So I'm Clayton Trevelyan, building official with the city of Tucson, and I'll pass to Angie.
Angie Reese, City of Tucson.
Christina
Ben
Anaya.
Person, residential reviewer, and Jeremy's here with me. Okay.
Christina.
Hey, Christina Anaya, management assistant, long range planning, City of Tucson.
Great.
Go ahead, Dan.
All right. I'm, of course, Dan Ice, Chief Building Official with Pima County. And I'm not sure, I might be the only one from Pima County on the meeting. Oh, there's Chris.
Just in time for introductions, Chris. It's all you.
Chris Poirier, Pima County Development Services. Hello.
And then let's pass it over to the consultants, Charles.
Yep. Charles Stone, Fisher Moran Stone. We are consultants to the city of Tucson, and our role is to provide assistance in what we all hope is an update to the lighting code. And
Awesome.
I'm joined by
I'm Hank Forrest. I'm part of the team here at Fisher Moran Stone.
And Katie's a Fisher Moran Stone as well.
Okay, I think that's it.
I've been asking to have a chance to talk and give background, even though I'm sure you guys all know parts of what I'm going to say about astronomy activity in the state of Arizona. And then I'm also happy to have a dialogue or discussion about how we currently measure sky brightness. I didn't have time. This meeting, from the time I asked for it, it got scheduled faster than I thought it would be, which is great, but I didn't have time to pull together all the slides on how we measure sky brightness, but I have a few examples and we could set up a follow-up meeting about that. And then if necessary, but I think this audience probably knows the difference between various types of lighting fixtures and why astronomy has a strong preference for certain choices. But I can also show some slides on that. But what I thought I'd start off with is just an introduction to why astronomy really values and appreciates the opportunity to work from the state of Arizona. And hopefully you are seeing a white dome with some yellow text. And this white dome, Stewart Observatory, was the first research telescope, first research anything at the University of Arizona. I'll share a little bit of the history in a moment. But we are keenly aware that we're located on the land that was originally inhabited by indigenous people. There were 22 federally recognized tribes currently in the state of Arizona. And astronomers in particular, we need to go to mountaintops in order to be above as much of the Earth's atmosphere as we can get. And that the mountaintops all across the world end up being sacred to anyone or important to anyone who lives near them. And they often were one of the last nations to get a reservation from the federal government, and they were not relocated. So they have hundreds and hundreds of years of stories associated with the mountains that we have our telescopes on. And we can't really change it. The lease that we have through the federal government for Kitt Peak, which I'm going to talk about in a second, is a perpetual lease. You wouldn't really be allowed to do that anymore. It's sort of like if your great grandparents gave somebody the right to set up in your backyard and you couldn't do anything about it. So it becomes a matter of respect, and we try very hard as we move forward to have good relationships with all of these groups on whom we depend. And we also, Kitt Peak National Observatory is one of all the little dots you see on this map. The state of Arizona has one of the largest concentrations of working research observatories in the world. In North America, it's the highest concentration. All of us came here because of the good weather. clear skies, as you see in the upper right picture, and the dark skies. And you can see the glow in that lower right picture of the sky over Tucson and Phoenix. That's scattered light, light that originally came out of a light fixture, either directly went to the air or reflected off the ground and then into the air, and then scatters off aerosols, molecules, dust back towards the telescope. And we care most about what the darkness of the sky is directly overhead. We're looking through the smallest amount of atmosphere there. And so you can see, I don't know if you can see this arrow moving, this cursor. You can see Tucson, the light scattering from Tucson, and the light scattering from Phoenix. And even though Phoenix is a lot farther away, it's bigger, so it's contributing almost as much. And there is scattered light here. It's just hard for your eye to see. So back to this map, the two big concentrations, and by the way, please feel free to interrupt if you have questions. I'm not in any way offended, or if I'm going into something that you don't really want to hear about, or is confusing, just please speak up. So the northern concentration of telescopes include the U.S. Naval Observatory, Lowell Observatory. This really is the Discovery Channel television station. They've renamed recently, but so they're not as big a partner as they were, but for the first decade or so of that observatory, it was doing a lot of public outreach along with science. Kitt Peak is here. Yeah.
What's the difference between the red dots and the blue dots?
The red dots are smaller observatories, some of which are like commercial, semi like bed and breakfast, dark sky type telescopes, as opposed to major federally funded, largely federally funded or state funded observatories. So Kitt Peak National Observatory, I used to be director of Kitt Peak. I came to the University of Arizona. So I've been in Tucson, Arizona for 40 years now. I spent the first 20 years of my career at the National Observatory. And now I've been at the University of Arizona since 2012. When I was director of Kitt Peak, I used to give talks a lot about Kitt Peak, but I don't very much anymore. So my slides are a little out of date. I'll get to that in a second. Mount Lemmon and Mount Bigelow and Mount Hopkins are where the University of Arizona, along with Kitt Peak, has telescopes. We also have telescopes on Mount Graham. Up in the north near Flagstaff, Lowell Observatory, U.S. Naval Observatory, and Discovery Channel. Lowell Observatory is the oldest observatory in the state, and we come a close second. So Kitt Peak, so Stewart Observatory started back in 1918, but Kitt Peak opened up in 1950. It was the first federally funded ground-based optical astronomy observatory. The growth of astronomy over the last 250 years in North America is initially everything was privately funded. Then the Cold War started, and everything associated with space or basic science started getting a lot of money invested in it. And that's when the national observatories, the National Radio Astronomy Observatory and the National Optical Astronomy Observatory got created. Hayden Meinel was given the task of finding the best site in the US for the National Observatory. And he needed the following criteria. He needed to be high, to be above as much atmosphere as he could get, but not too high because he wanted to be able to do construction safely. And back in the 50s, everybody had to work on the site, even at night. So you didn't want to be too high because it was frankly hard to work at 14,000, 15,000 feet. You'd have to have a pressurized room. So, and then a very important criteria was to be close to an educated workforce to provide the engineers and technicians needed to keep a facility like this running. And the final sites came down to Southern California and Arizona won. You can see now on this aerial shot of Kitt Peak, you can see what is now closed, the McMath Pierce Solar Telescope. A few years ago, this was the largest solar telescope in the world for 50 years. But a few years ago, the Daniel K. Inouye telescope, also funded by the government, opened in Hawaii and made this one out of date. But the Mayall telescope here, the 4-meter, and the wind telescope way over here, 3.5 meter, are still world-class facilities. You'll hear about the Mayall. There's a DOE Department of Energy project, several $100 million project, doing a map of the sky with spectra as opposed to pictures of all the objects. That's a 5-year project that they're in the middle of right now. The WIND telescope is studying exoplanets, planets around other stars, and that's funded at the moment by NASA. The University of Arizona has a group of telescopes here, and then a radio telescope farther down the ridge. This telescope is a 2.3 meter. Space Watch telescopes are right here. These are involved in finding asteroids that will hit the Earth. You'll hear about them in the news sometimes. In all, there are over 20 telescopes up here, and there are over 40 institutions, University of Wisconsin, Indiana, Illinois, Princeton, Penn State, UC, that have telescopes on this site. So all of those people are coming to Arizona to use these facilities. The national facilities are open to anyone in the country. Best ideas, get on the telescope. This is located on the Tucson Reservation. Almost all the other observatories in southern Arizona are located on U.S. Forest Service land. On the left is the Mayall 4 meter, and on the right, the 3.5 meter. You can tell how things have evolved over time. This telescope was dedicated in the early 1970s. It has what's called an equatorial mount. One of its axes for motion of motion that it's moving around is aligned with the Earth, so that you only have to move the telescope to track the star or planet that you're studying in one direction. The WIND telescope is more modern. It has what's called an altitude elevation mount. It's like a gun turret. You're going to be moving on in two directions to track an object. This, along with being able to make the mirrors, this telescope had a mirror made by the Mirror Lab here at the University of Arizona. It uses our ability to make what's a mirror that has a very sharp or very steep radius of curvature, means it looks more like a steeply curved bowl than a flat mirror. Allows you to bring the light to a focus faster, more quickly. So the length of this telescope is much shorter than this one, even though they're about the same size. And when you can make the telescope short, it fits in a smaller building, and that means it costs less. If you go back here, the Mayall is by far the biggest building on the mountain. Here's the WIND telescope. It's just built 20 years later, and it's in a much smaller building. So this is just another shot showing that the telescopes are spread out along the ridge of the mountain. This is a list just to remind me to tell you that we have telescopes spread out all over Arizona: Mount Graham, Kitt Peak, Mount Bigelow, Mount Lemmon. We also have telescopes in Chile, and we help operate telescopes. We occasionally are helping to operate telescopes in Hawaii as well. The biggest telescope that we operate is currently still the biggest in the world on a single mount. It's the Large Binocular Telescope on Mount Graham in southern Arizona. It's an international partnership with the Germans, Italians, and then other U.S. universities like The Ohio State University. The University of Arizona has about a quarter share of it. Just to So we're constantly working to raise the money to keep it operating. But the construction cost in today's dollars would probably be around 200 million if we were going to try to replace it. This is the MMT up on Mount Hopkins. So you can see Mount Hopkins probably from where you're working in Tucson. It looks like it also has one of our mirrors in it. This was an upgrade in 2001 from an original design that had 6 smaller mirrors in it. This was the first Observatory, they use this new compact building where the whole building rotates. So that's a turntable basically, and the whole building rotates. Both Kitt Peak and this telescope would be high on my list to try to do a tour. We'll talk later about getting a tour. This one I think is particularly useful to see because you can see towards Tucson and see to the south and see how the sky brightness changes. This is Mount Lemmon. I think you can tell where the city is. City's that way. And these are the small telescopes up on Mount Lemmon that include those used by the Catalina Sky Survey, which still finds more than half of all the asteroids that threaten the Earth and has found 6 of the 8 that have been identified before they hit the Earth. So it's still funded by NASA. It's a major program. It also includes the telescopes that we use for our nightly public outreach and for the Mount Lemmon Sky School, which brings students from around the state up there for 1-day to 5-day stays, where during the day they study ecology and biology, and at night they study astronomy. And they're usually middle school to high school with some elementary school groups. So a little bit about the history of astronomy at the University of Arizona. The University of Arizona started off with Old Main. It was founded in 1885, but it didn't really have students until 1891. You can see this amazing photograph of students in 1896, so a few years in. There's several things striking about this. The number of women, the Western universities had a much higher percentage of women in their classes at this time than the Eastern universities. And there were only 2 majors at this point, mining and agriculture. And one of the agriculture students was, mining students was a woman named Clara Fish. And she became good friends with Andrew Ellicott Douglas, this man here, when they were both working up in northern Arizona. And when they both found their way back to Tucson, she introduced Douglas, who was a new professor at the University of Arizona in physics, to Lavinia Stewart, who was living in Oracle, Arizona. Or Lavinia and her husband Henry had moved with their adoptive kids, his nephews, to Arizona because of the health of the kids. They had trouble breathing, asthma, and they were worried about keeping them healthy, so they settled in Arizona. And she was an amateur astronomer, had her own small telescope, and she gave the first large philanthropic gift to the university in its history, $60,000 to build Stewart Observatory. The money was actually given in 1916. World War I delayed things a little bit, but in 1918, what became known as the All-American Telescope, because it was the first telescope built with all US made parts, was dedicated on April 23rd, 1923. And that was also the first significant basic research being done at the University of Arizona. Since then, astronomers have started all the things on this slide. I don't know whether you know about the Tree Ring Laboratory, but the Tree Ring Laboratory, Douglas, the same person who's founded the observatory, wanted to understand the history of the sun. The sun goes through cycles of being brighter and dimmer that are correlated also with whether you have a lot of sunspots on its surface or not. And he wanted to see if he could understand whether the sun's behavior 1,000 years ago was the same as it is now. So he wanted to find a fossil record or some record of the past behavior of the sun. His idea was to look at the growth of trees over time, because if the sun is changing its brightness, he was hoping it would affect weather enough that you'd see a record of the changes in the growth, the tree rings of trees. And it turns out he was right. You can do that. It took about 60 to 70 years to actually prove that. But in the meantime, the ability to date when a building or an early archaeological site was founded based on the trees that are found on that site revolutionized a lot of things in archaeology, and also gave us the absolute calibration or 0 point for the radioactive carbon-14 dating scale. So without the tree ring, research, we wouldn't have an absolute scale to the carbon-14 dating. I'm not going to go through all these other things. This is from a talk where I'm trying to make other points as opposed to giving you general background, but all of these things are related to what we call the space sciences at the University of Arizona. And it's unusual. There are only a few universities in the world now that have anything like the dendrochronology that's done at the Tree Ring Laboratory, and they're all founded by students that came here. Atmospheric sciences, all these departments are doing basic research. Richard F. Karras Mirror Lab, that's part of Stewart Observatory. We're unique. We're the only place in the world that can make these large optics for telescopes. And one of the reasons we're in Arizona is because it's frankly easier to take our mirrors to the mountaintops that are nearby than if we were somewhere else, although we do send our mirrors all over the world. So for the astronomy department, which it's my honor to lead, there's a wonderful feedback loop going where we used our geographic advantage of being located in Arizona to help attract really talented people. I can tell you, my kids are grown now, but it was easier for me to go observing, stay up all night, sleep a few hours, drive down to Tucson, an hour and a half from Kitt Peak, 2 hours from Hopkins, an hour from Lemon, participate in some event my kids had, and then go back up and observe, than if I had to fly from Princeton, New Jersey to Tucson and spend a whole week here. So it really is an advantage we have in attracting really good people. And once you have really good people, they help you do the space missions too. And down at the bottom here are just some of the many facilities that we've helped build or operate, and I'll mention a few of them in a minute. Having unique facilities and unique access, meaning more time to use these facilities than other people, enables us to do better science and also then continue to secure funding to do more science. And up here across the top are just some greatest hits. Here is an image of the Crab Nebula, and in the middle of it is an optical pulsar, and the counterpart, the first optical counterpart to a pulsar, which is a rapidly spinning neutron star, was found by two of our astronomers in 1969 up on Kitt Peak using the original 36-inch telescope that was given to us by Lavinia Stewart, or enabled by Lavinia Stewart. And at the time in 1969, this made news worldwide. It was on CBS Evening News, everything else. This was the first big discovery made out of Stewart that made international news. I'm going to skip this one because it's hard to explain, but this is an image of a cluster of galaxies and the hot gas in the cluster that helps prove the existence of dark matter. That was made by Dennis Zawitsky, one of our faculty and one of his postdocs back in the 90s. We took the first images of forming planets. That bright spot and that bright spot are forming planets and debris around a star. And then this one you've probably seen is an image of the hot gas around the event horizon of a black hole. And that was done, we're part of the team, I'm part of the team that did that work with a network of radio telescopes. So great science done by even more amazing people and staff and students using facilities that we design and build. The funding for all of this stuff, almost all of it comes from outside of the state. So this gets to the economics, which do matter a lot to the state legislature. So besides helping to train workforce, besides just doing basic science, the economics are we bring in a lot of money. The one I like is we have the economic impact of hosting the Super Bowl every 2 years, because people know that a lot of effort is put into trying to bring the Super Bowl here, once a decade. And we're doing it every 2 years. And the reason we're doing that is because we bring in about 100 to 110 million just at the University of Arizona, not counting the National Observatory, not counting Lowell Observatory, not counting any of the other observatories up on Kitt Peak. Just the University of Arizona is bringing in 110 to 120 million per year to do space science. And because a lot of that money is being spent to build things, we have a big impact on other related industries. I'll show you some of that in a minute. So this slide just shows all the things at the University of Arizona now that would be called space science. And that's a nice picture of the LBT again up on Mount Graham. We do engage the public as much as we can. This is from the annual spring public lecture series. We also have a monthly lecture series. This is Centennial Hall. We get good crowds. We have one of the largest academic programs, both undergraduate and graduate. We currently have around 75 PhD students, and we have around 350 undergraduate majors. Some of our more famous graduates, I'm just picking two. One is Brian Schmidt, who won the Nobel Prize in Physics in 2011. He was an undergraduate here at the U of A. His dorm room was actually in the football stadium. So one of the older dorms. And then Jane Rigby, who's the project scientist at Goddard for the James Webb Space Telescope, got her PhD with us in 2006. She just recently got the Presidential Medal of Freedom. The outreach program up on Mount Lemmon was named last year by Space Tourism Guide as the best one of the #1 of the best observatories to visit in the US in 2024. So it's on the Tucson Metro Chamber of Commerce has a Star Trail thing. I might have the wrong name, but this is one of the facilities in Southern Arizona that they highlight. I was mentioning our economic impact. A lot of it is because we do contracts with various companies, some of whom are based in Southern Arizona, like M3 Engineering. These are the groups that we currently do the most work with. M3 Engineering, they build major mining infrastructure and design it in South America and North America, but they also do a large fraction of all the telescope buildings. The telescope enclosures are the most expensive part of an observatory, not the telescope, not the mirrors, not the instruments, just the concrete and steel that's protecting the instrument. And starting with the Wind telescope in Southern Arizona and including the Large Binocular Telescope, M3 Engineering has been the company working with us to design and help us build them because they are experts at building complex facilities in remote places like mines. Raytheon, Lockheed Martin, Ball Aerospace, Northrop Grumman probably don't surprise you. They're aerospace companies. And then Cade, they do a lot of heavy metal work, and they're in Tucson. They were bought now by a Canadian company. These are the main federal agencies that we work with: NASA, NSF, DOE, but what's less well known is we also work with a lot of other national labs and observatories, including U.S. Naval Observatory and DARPA. Just an example of the diversity of what we do. This is a NASA Pioneer mission, $40 million project that launched at the end of 23, and then a little over a year ago was flying for 57 days. It's what's called a long duration balloon flight. This thing down here is a telescope. Here you can see it again. This is the principal investigator, Professor Chris Walker. This is very much, but on a larger scale, like the balloons that Worldview is launching in Tucson. And we have talked with them over the years about doing some flights from here, but this one, they really wanted to go to the South Pole because you can go, the winds take you in a circle around the South Pole and you can get continuous observing. And this is about as close as you can get to space without having to spend the money of a rocket. A Falcon 9, there you can see the telescope being lifted up into the sky. This is a much more gentle way of traveling than on a rocket. If you were going to go on a rocket like the Falcon 9, which could have lifted this, it costs 60 to 80 million just to launch it. By using a balloon, they can, for $40 million, they can build, and then for another 10 million, launch and operate the whole facility. So it's a much less expensive way of doing things. And the same faculty member that's winning that kind of international competition to do that kind of mission is also involved in training our students. And this is wonderful for our students. So Chris Walker is also the mentor of a group of students that last year had a small satellite called CatSat that was launched by a company called Firefly for NASA. It's a CubeSat. And they, in this one mission, got to experience what most of us have had to have a 40-year career to experience. And that's how hard it is to win a mission and then design it and build it and then get it launched. They were scheduled to launch on July 1, and the countdown goes down to like 2 minutes and then gets a hold. And eventually, to make a long story short, it got scrubbed. And then eventually they got launched on July 3rd, and we rushed out of the building because it was launched from Vandenberg. You can actually see the rocket here. This is the stage. This is launched from California, but you could see it from the U of A Mall. Here's the PI and some of the students. And then they rushed back in, and we're watching the live feed of there were a total of 10 satellites on board. And you can see the first 9 get deployed, and right before you're going to see CatSat get deployed, the feed goes dead. Okay, no worries. It looks like everything's going well, but then no radio signal from CatSat. 15 days later, an amateur astronomer picks up a signal from CatSat, and the students have been manning the antenna it passes overhead Tucson twice a day. They've been manning the antenna, trying to reach it. They finally reached it. It turns out it got stuck inside the rocket, and the rocket started spinning enough that eventually it shook the satellite out. And now on the right, you can see a picture that the satellite took. So in one 3-week period, they went through all the stress of thinking they'd lost their mission, lost 3 years of work, to being able to do science again. And this kind of an opportunity is enabled because we have people like Chris Walker, and Chris Walker's here because we're able to do the basic science that he wants to do. We're the only university to have built more than one instrument for NASA's great observatories, Hubble and Spitzer. And on James Webb right now, 2 of the 3 instruments were built and led by either Marcia Ricci, NIRCam, and George Ricci. This is the James Webb Space Telescope. These are just some of the images. In the interest of time, I'm gonna not go into these too much, but this little instrument cost over 70 million. She proposed to build it in 2001. It was completed in 2012. It didn't launch until 2022. And it's been since then that they've been doing all this amazing science with it. So that, if you think about that, she spent most of her career, 25 plus years, on one instrument. Now, she was doing other things at the same time, but that's the time scale that it takes for NASA to do big missions these days. Her instrument has been spectacularly successful, and in recognition of that, she won the Gruber Prize. We don't have occasionally, like Brian, you can win the Nobel Prize in physics, but there's no Nobel Prize in astronomy, but the Gruber Prize is one of the top prizes, and she won that last year. So the next generation of instrument builders that are going to be doing big things on the ground or for space are people like Carlos Vargas, who has a postdoctoral fellow here, won what's called a Pioneer mission, $20 million mission, because we have the engineers and technicians doing all the other things we're doing, that he could put together a strong competitive team for a small satellite that's something in between that CatSat I just told you about and something big like James Webb. This can be done in something like 7 or 8 years. But the next big NASA mission is a 15-meter mirror telescope. It's not estimated to show up any sooner than 25 years from now, and it's going to cost $25 billion compared to $10 billion for the James Webb Space Telescope. So we're working with the help of a foundation to basically, instead of $10 billion for a 6.5 meter telescope, we're taking one of our 6.5 meter mirrors that we make at the Mirror Lab. We're hoping to launch it either in a Starship or Blue Origin or one of the other next generation giant telescopes, giant rockets that are in production. You can see how the telescope fits inside the rocket here. We need to wait until they stop having what they call their unscheduled disassembly events. We don't want the telescope in the rocket when it's an experiment. So right now we were hoping to launch in 2028. Now it's looking like 2030. But if we can do this, if we can pull this off, we will have shown NASA, not that NASA's doing anything wrong, they're amazing, but that there is a way of taking more risk and having more frequent missions. And the foundation that's supporting us to do this has already taken up office space in central Tucson. They don't want to be publicly identified yet, but this would mean that there'd be a series of space missions being developed in Tucson over the next 30 years. Each would be around 300 to 400 million. So the biggest project that's funded that we're involved in right now is the Giant Magellan Telescope. It could have gone in the northern hemisphere or the southern hemisphere. The reason it's going to Chile is because of other major observatories that are sited there. You sometimes hear that telescopes are time machines, and this sort of bugs me because time machines are like the time machine in H.G. Wells' book, The Time Machine, or Doc Brown's DeLorean. They actually can take you to a different time. You can go meet your grandparents, right? We don't know how to do that. But what telescopes do is they help us observe the time machine that the universe is, because the universe is so unbelievably big that it takes billions of years for light to travel across it. So to understand this, you have to really internalize that the universe is really big, even for something like light, which moves very, very fast. The nearest stars are this ridiculously large distance away, 25.6 trillion miles. I don't have a good intuitive sense of what that is, but that's why we appeal to how long it takes light to travel the distance. Light is effectively traveling from your screen to your eye instantaneously. But if I take a picture of the puppy that my wife and I got during the pandemic, and I send it by radio waves, which radio waves are light waves traveling at the speed of light to the nearest stars, by the time the picture reaches those stars, and we know there's a planet there, we don't know if there's intelligent life there, but intelligent life there sees the picture and likes it. By the time they like it, the dog is 4 years old back on Earth. And by the time we get the message that they liked it, the dog is 8 years old. So we're not going to be having any rapid communications with anyone off of this planet for a long, long time. But that challenge of everything being so big gives us an opportunity to study what the universe looked like in its earliest history. So I'm going to make some real big assumptions. I'm going to ignore the expansion of the universe, the fact that the universe is actually getting bigger. I'm going to round the age of the universe off to like roughly 10 billion years ago. So when the universe started, matter came into being and started cooling, and the first galaxies formed. So think of that, think of each of these little puppy pictures as a galaxy being born. And over time, we all age at the same rate. And so after 7 billion years, the galaxy is at intermediate age. And today we're in old age. And for the most part, most galaxies started forming at the same time. But if you take a selfie baby picture and send it out to everyone else, it takes a long time for those pictures to reach you, especially for the ones farthest away from us, 10 billion light years away. So by the time those baby pictures reach us, all the galaxies are older. But what do we see? The most recent picture we have for the most distant galaxies is a baby picture. The ones that are at intermediate distance to us, we see them at intermediate age. And the ones closest to us, we see as the same age as us. So if we want to see a young galaxy, what it looked like, we have to go look at the most distant galaxies. And that's why we need this. And the most distant galaxies are going to be small and very faint. So we need a telescope that can gather a lot of light and have the spatial resolution to see fine detail in the galaxy. So to understand what more light means, we're usually trying to study something very faint. So here's a picture where it looks like noise. But if you had more information, okay, it still looks a lot like noise. If you get enough information, okay, it's a picture of a young girl. Spatial resolution is a harder thing to understand. This is a picture of the event horizon around a black hole. It's in the center of a galaxy that's 53 million light years away. And the ring is about the size of our solar system. So this is like resolving the hole in a donut on the surface of the moon. So to do that, so if you look at the planets with your eye, they look like a little dot. If you use a small telescope like Galileo did, the resolution of the planet is you see the disk, you see the atmosphere, and the moons of Io, the Galilean moons, Io, Callisto, etc., look like little dots. If you use the LBT and you look at planets around other stars, you can actually see them orbiting around other stars. This is James. This is, I guess I skipped some slides. I'm going to skip out of this anyway, because the point is, this is what a telescope like Hubble would see of a crowded star field. This is what James Webb would see. And this is what the Giant Magellan Telescope will see, which is a 25-meter telescope that we're building at the Mirror Lab. All right, now I'm going to switch to a different presentation to just talk about sky glow or scattered light off the sky a little bit. And our consultants, I know a lot about this too. This is a picture of the night sky that I showed earlier with Tucson and Phoenix. This is a series of pictures taken from Kitt Peak, 1959, 1980, 2003. You can see how the city has grown. One positive thing is not all of the land that could be developed has been developed, but a lot of it has. So if we can get, if we can get the lighting to be good lighting, we can sort of predict what's going to happen in the future.
Just as a clarification, Buell, those
Yeah.
pictures were of Tucson, is that correct?
Yeah, that's Tucson. Yeah.
Okay,
that's
thank you.
Tucson. Sorry, yeah. And we have some that are more recent. It's one of the things I didn't have time to do for this meeting, but this is from, frankly, a 2010 talk.
Where are these taken? Are we?
It's taken from Kitt Peak.
Oh, okay, all the way up. All right.
Yeah, this is taken from Kitt Peak. This is also Kitt Peak. That what you can see here is the male, and that's Phoenix. Now you can see that what we care most about is not what's going on at the horizon, but what's going on up here at the as you look more closely to straight up. So there are lots of things that I just want to show a few examples that I pulled in a little bit of a rush this morning of how it's possible to still have plenty of light where you need it and avoid having the light go where you don't. This is before the most recent renovation of the lighting. This is after Musco did the lighting for the football stadium. You don't need measurements to be able to tell that this is better, but we do have measurements. One of the ways we can make measurements is we can use small wide field telescopes like this one that's in this little portable trailer where we can take it to a site and make measurements. This is the same telescope on Mount Lemmon. In this telescope, in this picture, it's on Kitt Peak. And you get measurements of how bright. Here's close to the horizon, close to the city, and then you can see it's darker. You can make measurements of how bright the sky is. There is going to be variation seasonally. Some parts of the sky glow are not caused by scattered light. They're caused by emission by molecules and other things. One of the reasons we care about the blue light so much is that's one of the wavelengths where the sky is intrinsically the darkest, where it's not light being originated from the air itself, but it's mostly scattered light. So what one of these plots, I'm not going to go into detail today, but what these curves show are measurements of how here, this means the sky is darker than here. And you can see this is hours since noon. So, 6 p.m., you can see this is winter time. This was summertime. But we're able to make these kinds of measurements. It's hard to say, oh, this part of Tucson is causing the sky brightness to be the highest. But there are studies that exist. This is one that was done by John Barrington and his colleagues, where they measured the sky brightness over Tucson before and after the streetlight conversion a few years ago. And so they were able to use measurements that they made. This is a satellite image, but they were able to make measurements from flying over the city and other things. They have a nice paper that details what they did, to look at how the sky brightness changed. And so here's just some other examples. Here's Saguaro National Park, where you can see the light, scattered light from the city of Tucson. So yeah, it gets darker over here, but this part is getting pretty dark. This is Mount Hopkins, that's 6.5 meter. And so this is still pretty dark. This is what we're trying to protect. Okay, so that's that, and I'm gonna pause now. Because I didn't really give you guys a chance for questions. So questions, and then I think you also had on the agenda that the consultants were going to talk about some of their capabilities, or is that another meeting?
Yeah, hopefully, yeah, they can share. I really just included the items that you had mentioned in your email for
Okay.
agenda items.
Okay.
But yeah, if Charles or someone from FMS can be prepared to speak about what resources you have available to assist this effort, really just speak to your capabilities.
Well, our practice has for 50 years. So, Buell, I'm speaking to you.
Yeah, okay.
Our practice for 50 years has focused on what we call architectural lighting. The British call it specialist architectural lighting consultants, if you like the British term. And our focus in that whole time has been to assist architects, owners, indeed developers, occasionally municipal bodies, to do what we would generally say good lighting. What is good lighting? Well, good lighting is many different things, including lighting that is beautiful. And I always have said, you can be green and beautiful at the same time. All this has occurred in a period of time where I have witnessed in my career, which really began in architectural lighting in 1980, and it witnessed in my career the transformation of technology from discharge and tungsten sources through a brief flirtation with compact fluorescent, many attempts at various improvements to discharge technology by using phosphors and chemical magic and high pressurized tubes in the lamp bulbs, and now underwent, since approximately 2005, a rapid adoption of what I call the LED tsunami. So that's one way to look at the context of what we bring as experience across that. And your photos, indeed, the trio of photos showing the Tucson sky brightness situation occurred at 3 points in that technological journey. I think that's quite interesting, actually.
Yeah, and I was missing the most recent one. I have one, but none of the ones you saw had the LEDs yet. But you're right.
I want to see that. So then you overlay this with all the other things, some of which you touched on, which frequencies matter, which spectral wavelengths matter the most to you. I'm familiar with the life and work of the late David Crawford,
Sure.
and what that has meant in terms of making Tucson the beginning and carrying the flag worldwide for what has become the dark skies movement, you might say.
Right.
So we bring capability.
By the way, Dave was the project scientist for the Mayall telescope. So he led the construction of that telescope.
I didn't know that. Okay.
Yeah.
Well, I could go on about this, but I just thought I would give you, speaking to you directly, really, and using
Yeah, no, I
tech talk
actually,
give you a sense.
I appreciate that. And then for the rest of our colleagues that are on, let me show why signs end up being such a challenge for us.
Indeed. And I should mention my colleagues, Hank and Katie. Hank's been with me for decades, and Katie just over a decade.
Yeah.
Have all the same experience. Hank and Katie are particularly technically competent due to the nature of their experience in our practice, as well as being really nice people.
Yeah, it's great.
and-
It's great to have all of your help because we had an outdoor lighting code meeting last week. I think it was last week, and people were already coming up with wish list questions for you. So we're looking
Well,
forward to it.
I want to add that for the last 8 years, I think it might be 9, I have served on an IES Illuminating Engineering Society committee, which was originally called the Lighting for Outdoor Public Spaces Committee. Now it's been subsumed into something called the One Committee.
Right.
But being concerned with all aspects of lighting in the outside, and our basic principles for being good stewards of the energy we burn to make light is that put it only where you need it.
That's right.
Tailor it to the wavelengths you need the most, that it benefits to humans, flora and fauna. And also that implies immediately and is most relevant. I think if there's one single most relevant comment, it's that all lighting should be cut off and maintained to be restricted, you might say, it's not quite the word, to the site where you're using it. And
Right.
indeed, you made a comment about the 7% reduction with the introduction of the LED street lights. You know, it's pretty obvious to you and to me that that's primarily because of the better optical control
That's right.
that came with those fixtures, and therefore there's less light going horizontally and up.
That's right. That's
And
exactly right.
indeed, a focus or one of our primary discussion points with the whole group here has been about light, what we call light trespass, generally speaking, or just being responsible in your use of light because you want to use cutoff fixtures. So
That's right. We have to make it easy for the public to know to pick the right thing. That's one of the things I'm happy
Yeah.
about our code is it's one of the better ones at being easy to understand, but it's relative. It's still hard to understand for many people.
So just to close on this, our focus has been to try to simplify and yet make sure we land on the things that are in these paragraphs in the code that every person can understand. It's
Right.
not so technical. There are going to have to be technical things in it, but here's your sign slide. Oh dear, look at all that going
There's
up.
one of them, and this is both a good and bad story because, as I'll show in a couple slides, signs like this are infinitely better than signs like this. But the one problem with this is that this is after all of these places are supposedly closed. So that gets to one of the things we hear a lot about is how to do, if we're going to have a cutoff at some time after closing, how do you enforce it? Again, a sign like this is amazingly friendly because the blue letters here are like 6 nits. Now, you know, what's a nit? It's a measure of the surface brightness, how much brightness per square meter or millimeter, whatever, is coming. And we've been trying to get everything below 200 nits. That's trivial for a sign like this. This is only 6 nits. The night sky is 1 to 2 nits. During the day, the sky is a lot brighter. It's 8 to 10,000 nits. So the problem the sign manufacturers have is they want signs that are visible in the daytime and at night. So that's the problem they're dealing with. And we want signs to be no brighter than they need to be. Because unfortunately, it's hard to have a sign and not have the light go up above the horizontal. Here's like, these are actually fixed. Arizona Pavilions has actually gotten rid of all this white light now, but this is an old picture I have and shows that this is so bright that it was illuminating the parking lot well enough that the parking lights thought it was daytime. So they didn't come on. It was a light sensor.
So Buell,
Um,
I had some response for you as well, in addition
Oh,
to
sure.
what Charles
Sure.
said. As far as resources go, I mean, while we're a small company, we're one of the larger lighting design firms, and what that means is that over the years, it's allowed us to basically not specialize in a particular area of lighting. We work on everything, so it could mean, not just commercial or residential. It can mean exterior, interior. It's allowed us to really extend into every imaginable aspect of where lighting design might be needed. And as we work all over the world, so as we work in different places, and we're often involved in exterior lighting, it forces us to get to know what lighting requirements there are in
Right.
each of these locales, and it informs us as to whether a place does in fact have any sort of lighting code or not. Most often it doesn't. So what we end up drawing on is the IES and dark sky of reference matter with that, because that's something that we're intimately familiar with. And I mean, I myself have been a lead AP for over 20 years, and usually our biggest role for on lead projects does amount to the light pollution credit. So and everybody is typically, the whole team is very shy to get involved in that, so they're happy to sort of put it all on us to determine what the lighting zone is, or what complies, or make proposals along those lines. So while much of the observatory specifics you mentioned were interesting and not something that we would necessarily hear about, a lot of the issues that you're contending with are very familiar to us. I mean, we knew even beginning, just when this project started for us, we knew that Tucson had a very important and very large observatory industry, and which drove Tucson and the Pima County to have a more than much more than a normal lighting, not just a lighting code, but also a lighting code that goes much further than we would typically see in most places. Even though we did immediately sort of start to question the whole lumens per acre idea in terms of, like, where did that come from? We're not, we haven't really seen any science that supports a code that translates into something on lumens per acre. And it also just seemed to us that, while we understood that was intended to be, or at least what we heard was that was intended to make things more compliant by making it sort of easy to digest and people could figure out what it is. I mean,
Well,
there's a lot of ways.
Yeah, if you don't mind me interrupting for a second.
No, go ahead.
The science motivation for it was struggling to figure out how to keep the total amount of light below, just to control what's the total amount of light. So
Right.
it's great to say the energy code will do it, except
No,
it doesn't.
It
it
doesn't.
doesn't. Yeah,
It doesn't.
Okay.
At a gross high level, looking down at the albedo of the Earth and dealing with the reflected light and then the direct light components, you get the lumens per area approach. But if you want a compliance approach, we're thinking maybe the cutoff and the prescription of luminaire types might actually give a higher level of compliance in the long term. That's one.
And I think we're open to hearing how that would work. I mean, this came up at the last week's, I think it was last week, or whenever the last Outdoor Lighting Code Committee was, maybe it was 2 weeks ago. I think the biggest challenge, what motivated the current revision, is exactly what you mentioned earlier, the transition to LEDs, and trying to educate ourselves and everyone else about the fact that the LEDs just behave very differently than the lights we're used to. Here is a plot that not everybody will enjoy trying to understand, but it shows the problem that we have from, we use this color temperature system was designed to describe black body emitters. Black body emitters normally have a shape that looks like this, where being high on the y-axis means you have a lot of light, and then on the left-hand side, this scale this is blue light, and on the far right is red light.
And
so
Bill, it's become a kind of placeholder or shorthand for the perceived color of light. That's just a long way from what you're talking about.
Exactly. And so the challenge we've had, I mean, I know this is more for our non-experts. I know you guys understand what color temperature is. I know you understand the challenge, but when when most of the lighting was low pressure or high pressure sodium or other things, it's a big spike in the red, nothing out here in the blue.
Right.
And this extreme blue light, really, we call it junk lumens because it doesn't really help people see as much as this light. And the other problem we have is the energy ratings. The Department of Energy gives bonus points for this light. So if somebody puts in a phosphor that reprocesses the blue light and moves it to the red, it comes out as less efficient, even
Yep.
though it's actually helping them do what they want to
Which
do.
is, of course, what we want is blue pump phosphors because they give us back R9 and R14.
Right. And so the biggest thing you could help us with is finding a way, because we've tried twice now, of explaining why we need to modify, whether it's lumen caps or whatever it is, the numbers need to change from what it was under the old code to the new code because the technology has changed. But what the developers and businesses fear is that we're taking something away, because what they hear is we're lowering the lumen caps or we're reducing something. And we need to be able to show that that the amount we're lowering it, and the people that made the current suggestions they are knowledgeable. They included people like Dennis Kuhn, lighting designers. They were trying to convert for the fact that an LED doesn't reduce its brightness as quickly or as instantaneously as some of the other lighting choices, and that the other light, we knew that some of the light was lost inside the fixtures with some of the other luminaires, whereas the LEDs, more of it's coming out. So explaining the color effect, getting agreement on what is good color rendition. I think the only way we're really going to ever get good agreement on that is to actually go out and take people to see different
But
deployments of lighting.
I'm very encouraged. I'm very encouraged by the things you're saying because I think we can help you and you can help us figure out this this explanation, if you will, because there's a lot of good practice and advice in the IS body of research and published recommendations to address things you're saying.
Right.
There's a lot of good stuff there. And I actually think we would be giving the developers a simpler and better toolkit and their design teams going that direction that we've been talking about, where you're limiting certain kinds of distribution of fixtures that causes lumens to leave the site, especially upward, horizontally and up. And I actually think you can get everybody on board if we can frame this properly.
We're open to it. A lot of this is communication, and then also making it easy to follow through on it, right? It can't be something where business perceives they have to hire an expert in order to every time they want to do something.
That raises a question. I made apparently a mistake when I said I didn't think that the homeowners, all the residential guys, I'm sitting here in Tucson in the foothills, I didn't think that all of that added up. I wasn't sure what it adds up to, because if you have a code that you're asking homeowners to comply to, it's got to be straightforward and simple. They don't want to do arithmetic.
So after the curfew, it adds up to being, I would have said the biggest contributors, but it's hard. It's actually there's certain, back when people were using metal halide and other sources that had emission lines in the spectrum of the light, it was easier for us to identify who is the light source, right?
But now
But
you're saying when you turn off the stadiums, and if we
yeah,
dim down the street lights to 60% at 2 a.m., I don't know exactly what the current
yeah.
thinking is on all that, and the playing fields are all off the tennis courts and so forth, uh, what's left? What percentage of the pollution coming from homeowners?
So I'm not going to give you a number tonight because the latest data people are still analyzing, but it's still very
Yep.
significant. And part of that is because a lot of the residential lighting is still old, grandfathered in, not compliant. So it's legal non-compliant.
Yep.
And um, the new stuff, sometimes it's these motion sensor lights that are not, as you said, full cutoff, so it's hard.
But
But
everybody's going to have to replace those because you can pretty soon you can't buy the incandescent or even a screw base. It's going to get harder and harder. So interesting.
So Buell, where I was
Yeah.
starting to go, I watched the meeting tape that is on the
Yeah.
website that I think Dan provided me a link to with that. And I heard a lot of discussion about color temperature in
Yeah.
the recent meeting, which all made a lot of sense. I mean, from our perspective, I mean, with LEDs have gotten certainly better, that it does make sense to us, to start looking at lower color temperature sources, because you can still get very good color rendering out of them.
Right.
And,
So
we
that's
can,
the second one. Thank you. If you guys
Yeah.
can help us show
so we can
how-
certainly get rid of the
yeah.
blue to a large extent and still have good quality lighting that I think people would like, as well as, amber is certainly, something to look at for the really critical areas. So it's, all those
Right.
things seem to make sense to us. But
So
you're right. I think mock-ups would make a lot, would really go a long way for people to understand what those are about.
I'm glad to hear that. The third thing I want to make sure I get out just for you guys to think about is, the code, our code since its inception has been most restrictive the closer you are to the
Observatories.
observatory. And let me just, for our colleagues, see if I can show a slide that sort of tries to communicate this.
And really, your map really sort of translates that in a way where there's like concentric zones around the observatory zones.
Yeah, that's right. I mean, but the idea is that the geometry of where the light source is relative to where you are, so the sky is blue because the sunlight, we see sunlight that comes right to us, but there's also sunlight that hits air here and then scatters to us. And so the difference of having air here, you can see the moon looking through the Earth's atmosphere. Where there's atmosphere, you get light scattered. If you had no atmosphere, it's black. So that's, what we're trying, if you try to observe a planet during the day, you can. Here's a planet during the day, but it's hard. This is Venus. You can see Venus. You can't see a faint galaxy because during the day, because the galaxy's still there. There's a galaxy there somewhere, but you can't see it because of the scattered light. At night, if there's no street lights, that sky is about as dark as it is if there was no air. Here's an example. Again, so if you have light directly at the base of the mountain, then the light all the light that's reflecting off the ground is going to go up through the air, and anywhere in the atmosphere is going to scatter back down to the telescope. But when we looked at those pictures of Kitt Peak, the light that we saw in those photographs wasn't the problem, because that was going right to the camera. The light that was the problem was the light that went up above the observatory and then back down. So now that light has to go through the most atmosphere. So to be honest and transparent about it, the blue light scatters more than the red light. So that blue light might not get to the altitude directly above the observatory. It is going to make the sky directly over Tucson brighter, but not as much. Light in the center of Tucson is not going to make it as much as I'm fumbling my words here, is not as damaging to directly above Kitt Peak as it is to Mount Lemmon because it's closer to Mount Lemmon.
So
So
the two things that if you could get warmer sources in general going forward and in retrofits as they occur,
right,
and if you could enforce compliance on cutoff fixtures
right.
and really restrict light to only where you need it,
That's
you're
right.
making a lot of progress, and no one ever talked about the number of lumens.
Well, except
They matter,
it's,
but
but
it's
but they do matter, and we can show that when people comply with the lumen caps, those areas are lower than areas that aren't.
I see.
But I agree that if we can get more things like, good field lighting, right? Look
Yep.
at that. No, that gets back to your light trespass issue. Yes, stuff like this helps tremendously.
Yep.
The city of Tucson already banned billboards like this on the left.
That's
So
a
that's
great,
good.
wow.
But but digital signs, there's always a growing pressure for more digital signs. I mean, you guys already know this. Good lighting, I'm trying to find my favorite slide.
But Buell,
Um,
realistically, the lumens per acre approach to things really doesn't speak to light trespass at all.
no, but other
in
parts of the
terms of-
code, but even perfect lighting like this, still, if there's too much of it, this light does reflect off the ground, right? Roughly 20% is what
Right, but I
I've been
think,
told.
but I think where Charles was going with this is that there's no one or two things that are going to all of a sudden be the magic bullet here. There's going to have to be a few components like color, the cutoff, and amount of light where you actually need it
Yeah,
to do
totally
that. I
agree.
mean,
Yeah,
this
I
doesn't
totally
speak
agree.
because this slide doesn't speak to, all right, that bright yellow area, below the fixture. How much light is being provided there? I mean, is that 150 foot candles or what?
Yeah,
It doesn't say.
when I speak to this, what I try to talk about is that the light environment that you're in affects your eye's ability to see. So you can get by with a much lower level of light in this parking lot. The reason you end up having brighter light at the entrances is because people are fumbling for their keys. They want to see the key lock and stuff. To walk safely across this parking lot, you can have a really low level, and
So
yet
we-
people don't agree what is safe.
Well,
Yeah.
actually, we have the IS recommendations and the new RP, which establish what those levels should be.
Right.
And
So I challenge you to show how they came across whether those are safe, how they decided it was safe or not. Here's an example.
Yep.
There's a person, you can see them. He's still there. He's just underneath the light post now. Okay?
exactly.
So, this is the lighting in this case isn't more safe because you got this really big bright glare bomb.
We're in agreement.
Yeah.
And
And
so that's what the people on the RP committee, we spent a lot of time and had a couple of experts dealing with this exact question because the
That's
feeling
right.
of security, for example, is when you see people's faces.
right.
It takes a very low light level to do that. So
That's right.
many of the light levels in the new RP are a little lower than they were before. And so
No,
that's what
yeah,
the
we did
developer has
lower
to
them. We did lower them. We thought we were
do.
estimating.
I mean, in
Oh,
the
you mean in the
IS,
IES guidelines? I
yeah,
get it. Okay,
because
yeah.
the developer who builds a building, his or her consultant has to refer to standards because if somebody falls down on the crosswalk, the experts have to be able to say, well, it wasn't the fault of the lighting because we met the standard.
Yeah. So here, one of the things we run into though, guys, and I'm sure you'll empathize with this, is this costs less than this. That costs less than this. So if you're a developer and
But it's ugly.
if you already bought this, you don't want to retrofit to this.
Well, that's where the rubber meets the road, and the first slide is ugly.
Yeah. Everybody agrees it's ugly, but if they've already bought it, they
Yep.
feel stuck with it.
Right, but then there's a question of whether it meets guidelines or not. If it doesn't meet the guidelines, it doesn't matter how cheap it is.
Right.
You've already spent too much money.
So to convince besides the astronomers, the other constituents that really care about the dark skies are people that just moved here to feel like they're living in the natural Sonoran Desert more than Chicago, or people that care about wildlife, not, or human health. Now, human health always ends up getting debated, but the area of human health.
We agree with all of that.
Yeah, okay.
We're all in. So
So
And
for
there's
the
been there's been a
astronomy,
lot of research on all this, you know, that's
I know, but the astronomy community, the to convince the astronomy community to give up lumen caps, they're going to want numbers, right? They're number people. I'm part of that community, and so they're going to want to show how you can not inevitably lead to an increase in sky glow by having unlimited amounts of light, just by making sure that it's full cutoff.
well,
right,
we're
but we
never
can
saying
we can
unlimited.
easily show people
Yeah.
that the lumen caps, even the lower lumen caps that are being presented, are much higher in terms of foot candle values than what the IES would recommend in various areas.
Right.
the
So
lumen
we just
caps
have to
are
do some
already
simple math.
very
We
high.
have to, you guys will have to help us out with some simple math by just saying, okay, assume the whole area of Tucson is at this foot candle level. You know, is that going to end up being less than the lumen cap? So that'll convince them.
One of
But
the Buell, one of the problems here for all of us is that just as LED technology came out of nowhere, you might say, all of a sudden the world changed in a very
Yeah.
short period of time. We are leapfrogging forward in how to write codes to deal with this technology.
right.
I think that's what I've realized, and as we've spent time on this project so far, that what we go and review in other municipalities or in Tucson's existing code, we would never start there today because so much has changed.
That's
And
right.
so that I completely understand when you say we're going to have to convince people and we have to make a case. I get that, but change is always hard, and this has happened quickly. I mean, I imagine there are similar stories you can tell me about rhodium-coated parabolic mirrors and technologies and vacuum depositing of magic stuff on your reflective surfaces and optical telescopes that no one expected, that suddenly allow much greater pieces to be made. I don't know. I just
Sure.
made that up, but
Sure.
I expect there's similar stories in your world that you had to invent whole new ways of describing the problems. I think you're going to help us as much as we're going to help you.
Yeah. No, I think that as Clayton and Daniel, I'm sure will agree, we're about 4 years late, maybe 5, on when we thought we were going to have this latest update out. And so I think it's what we're hoping. I think I'm speaking for most of the committee, although we just got 3 new members who I don't know as well. I think we were hoping to get an incremental update out now. That means still using the lumen caps and stuff, because if we start doing a wholesale replacement, I think we're worried about how long it'll take. But that doesn't mean we really should be sort of constantly working on the next version. So I think we were sort of hoping, can we get a version out this year that at least does some of the major corrections for the LEDs being out there and fixes some of the errors that are in the old one, because you always find things. While if we were going to do a major change like not having lumen caps, I think will take. I can't see how that takes less than another year. But if you guys can
Well-
convince me that it
Well,
can be done
Buell,
faster,
I
I'm not
would-
against it.
I'd respectfully disagree with that in the sense
Okay.
that the lumen caps,
Wait. That's not our brief at the moment. Our brief at the moment is to help to assist all of you with one substantial upgrade to the code. It's not to do an incremental one and then an update, although I appreciate your argument about it.
well,
Yeah, that's fine.
what-
I'm talking to Clayton and Daniel as much as I'm
Yeah.
talking to you. It's
all right,
just,
but
yeah.
what I was going to say is that since the lumen caps, again, from what we could see, are really based on a somewhat arbitrary measure. I mean, it's not like scientifically based. So any sort of update or revision of
I'm
that.
gonna object to that.
Okay.
I'll get one of my colleagues, Richard Green or John Davis or somebody, to help go through how the original lumen caps were arrived for you. But it was based on looking at what the lighting was in 2000 when they first started to have a code, and
Well-
how do you stop it from growing? That
Well,
was,
that would be helpful because we've been
Yeah.
asking that question and we haven't yet been able to, hear about anything. But even let's assume that it was based on something fairly solid at the beginning. Any sort of update to that is going to start to turn into a fairly subjective, which I think is the reason you've been having trouble coming to some agreement on where do you go with it at this point.
well,
Whereas-
so I think the reduction basically by about 20% literally came by comparing the LED lights installed in certain fixtures to the existing lighting or the previous lighting. That's where it came from. But that's where I'm admitting we need help, because all the developers see, I mean, there are a lot of things that I understand the developers are frustrated by, and then there's some that I don't understand. The one I don't understand is they just see a reduction and they assume that's bad. Reduction must be bad, as opposed to just converting to a different light.
Yeah,
Um,
our comment on that as being hired, we're hired by architects and ultimately owners, developers to work on projects. If we were hired to do a project in Tucson under the existing code or a new revision of it using the lumen caps, we would almost completely ignore it until we'd finish the design, and then we'd go back and count.
Yeah,
Because
that's right.
it's not a design tool. It actually increases the cost of doing the work, because you have to
So I think
have
that's
to
the best
go through
argument
it
you have.
twice.
That's the best argument you have of convincing the current outdoor lighting code committee and the astronomy community of switching. But in order to close the deal, you would have to show us that if we take a certain set of parcels and light it the maximum amount as one could, the way you're doing it, it would fall under the existing caps, right? We have to do a few test cases to show.
Sure.
Except you would never, as a professional, you would never light anything to the max, because the developer wants you to use as little as possible because of their budget.
No, the developers want you to use what the California or Illinois or wherever their other branch is, where they've paid some designer like you to design to the code in that state. They want to carbon copy it and stick it in our state.
Some do, I
That's
suppose.
that
Yeah. That's not
my favorite example is like Toyota. Toyota tried to get an exemption to their sign because every other Toyota dealership in the country was brighter than what we were saying they could be, even though our limit you could still see. So you're right. If you're doing a custom design for Tucson, you're going to want to do it at the lowest cost that adequately lights what's going on. But if people have branding or something, which is what happens, then they just want to copy. And if you're in Las Vegas, you need your sign to be brighter because the ambient light is brighter than if you're in Flagstaff or if you're in Tucson.
Right. But maybe they're allowed to keep that sign on 24 hours in Vegas. In Tucson, they have to shut it off at 10 p.m.
Yeah, but if it's too bright for us, we're still losing 6 to 10 p.m.
Right.
And I
Or
mean,
whatever. Well,
yeah,
then
I mean,
whatever,
one of
whatever is the
head of
agreed
the
upon
national,
time.
yeah, the head of the National Sign Association in 2012 came to the city council meeting where the code was being approved and tried to convince us that astronomers didn't start working till 11 o'clock at night when the curfew started.
I don't think
And
that's true. I think when it
it's
gets
not true. We work all night, but the compromise is we accept that it's going to be brighter in the first part of the night, because people are up in the first half of the night in large numbers and need to be safe and need to work. But it doesn't mean we like it. So
Well, then maybe it's just relative to sunset in some way or something.
well, that's what
Yeah.
the original, yeah. But the look,
But we understand
this has been a very
questions
useful
that-
discussion. I think I understand where you're coming from and I appreciate it. And I'm not saying no, there's no way I could agree with it. I'm just trying to be transparent about what I know about the history of how this code was developed. It was not arbitrary. I can get somebody I was not involved in the early 2000 part, but we still have people who were, and they can explain. Dennis is one of them, actually. Dennis Kuhn, who's the vice chair.
It'd be good to hear that, I think. I mean,
Yeah.
certainly, generally speaking, it had to be what is the total number of lumens going up and what is the total number of lumens going down and bouncing up,
That's right.
and add that up somehow and
That's right. And
form
we,
a-
it was, that's right. There was an
lumen
estimate of,
count.
it was an estimate of what it is now. How do we not have it grow? That was basically.
I get that.
Yeah.
But I guess what we want to explore with you is, will you have better compliance? Because we have other constituents to satisfy. We have to satisfy, I say I say everybody here.
Yeah, yeah, we all do.
You have
Yeah,
to
we all do.
satisfy
Me
the
too.
developer. You have to satisfy the homeowner. You have to the
Yeah,
taxpayer.
I hope you can tell, I'm very empathetic with the developers that we want whatever we're doing to meet their needs and be simple. But the light that goes up doesn't help them. So
Well, actually, what we want is I would rephrase that. You want the developers to have to do the best, to act in the best civic interest. And we want a code that makes that possible for them to do.
but it also has to be easy enough. It not just possible, it has to be easy enough that they don't say Tucson isn't business friendly.
Like, of course.
Because if they say Tucson isn't business friendly in the code, then our council and supervisors are going to tell the Outdoor Lighting Code Committee, get us a better code.
So you want a couple of years from now, you'd like the word on the street from the electrical engineers who do lighting, from the lighting designers who do lighting, to all say, "Oh yeah, we love working in Tucson. They've got a great code. It makes sense."
That's right. Yeah, so color temperature is a really good example of how this goes, because you were talking, really resonated with me, Charles, when you talked about how you're sort of always out of date when you're writing the code and things move too fast. When we wrote the 2012 code, we all knew we'd prefer 2700 as the color temperature, but we accepted 3500 because there weren't enough fixtures.
You couldn't buy it.
You couldn't buy it, but now you can.
And the bean counters,
Right.
every time you lowered that color temperature, it got less efficient.
That's right. That
world
from
of
the reason we
LEDs
talked about earlier.
lost
That's
their
right.
expectation.
That's right.
So
That's right.
that gap closed steadily, and now you can get the 2700 source that's only a little bit less efficient.
That's right. That's right.
Than the
That's
whitish 35.
That's right.
So, that kind of disappeared via technology.
That's right.
And now what we have is these. I just saw a demo that is put up in the foothills of I think it's 1800 or 2000 Kelvin so-called correlated source, which is not all amber. It has a pretty good color render to it. So what's happening is the technology just keeps getting better and better. It's like outrunning us. So
right. So I know we're already lost one person. We're going to lose more. Let me just say that
yeah,
I found this helpful. I hope you found this helpful. I'd like to figure out, this is more for Daniel and Clayton, how we figure out where there is existing lighting in Tucson. I think we can work with people like Chris Monrad and Dennis Kuhn and others that have done installations that have these different color temperatures and things, where we could do a road trip of people to go see it. Because the hardest thing to discuss in our meetings is the difference between 2700, 3500 fixtures on whether something's got adequate color rendering. I mean, we're willing. So, for example, the car dealerships are a totally small amount of area. So if we can't ever reach a compromise with them that they feel they have to have 6,000 or whatever in order to have their cars look good, we're going to be able to live with that. But if every single parking lot in the city is at 4,500 when it could be 2,700 and everybody would be safe.
and it could be cut off.
And it could be cut off. Yeah, no, it's already required to be cut off. But if we could help people really believe that that's safe because they've seen it, that's a big part of this too. So,
I wanted to mention some have heard this, but I think you'll enjoy it. In my little area where I live, there are 90 houses, and I'm the shadow member of the lighting committee. I'm not officially on the committee. I didn't want that.
Right.
And we have got a code in place. That's a local, enforced by the board of trustees or whatever of the condo association, which requires 2700 Kelvin And
Excellent.
it's encouraging cutoff luminaires, and it will be tight. The screws will be tightened further. And we have now about 95% compliance.
Oh, that's fantastic.
And maximum, they insisted doing it with wattage instead of lumens because people can't count that high.
Yeah.
4 watts or 7, I can't remember the number. It's in the code. You can't have brighter than a 7 or 8, maybe it's 8-watt LED. That's the maximum. So there we have tackled, 2 out of 3. We've got the
Right.
lumen countdown, and we've got the cutoff as in the future. But we've got the lumen countdown, and we've got the color temperature down, and that's just my little neighborhood.
No, that's great.
And so it's interesting to me how I take that lesson and spread it out across town, and suddenly you create a movement for compliance. That's kind of my dream about this. You get everybody on board with this.
So I think that if we can get Metro Chamber and the major developers to believe the code we're presenting works, that's 90% of the effort, frankly. But anyway, this has been useful. And
Great.
Dan and Clayton, what do we do next? When's the next meeting? Can we make sure the next agenda, I'm not the chair, but can you check with Amy? It's okay to have the next agenda be maybe a chance for the consultants to talk. We should just make sure that it's on the agenda for them to.
So
help with
the
questions.
at the last outdoor lighting code committee last week, the committee agreed to have meetings moving forward on the second Wednesday of the month. I think
Right.
this is a tremendous help for everyone to plan their schedules accordingly so that we can
Yeah.
get greater attendance and involvement. But it is rather short now because that means our next meeting is next week.
Next week.
Yeah.
So
Yeah, it's probably too hard. We should still have the meeting, but we won't make much progress between now and next week. But I think the subcommittee is also going to meet with the consultants, right? Not just me, because
So
I'm
we
not
have-
on this.
we have a list of questions that are circulating through the committee members that
Right.
we're going to be transmitting to Charles and his team for specific requests of research or items to work on.
Great.
So we'll be distributing those questions soon. We're just waiting to collect all of the committee members' thoughts on the substance of those questions.
Yeah. So I hope Charles and Hank and
Yeah, Katie had to go.
Okay, that's right. I hope you all understand that one of the other obstacles here is if more than 4 of us on the code committee meet at once, it's a meeting. It's a public meeting. So like I've just learned a lot, but my colleagues weren't here. So you're gonna have to. I hope you'll be patient. I hope you'll be patient that you'll have to repeat things multiple times before everybody's heard what you're saying.
Well, I know something about your resume. It's pretty much an honor to have received your presentation and to be in the presence of a mind like yours. So
No, I know.
Talking to
My
someone-
mind's no better. I'm just obsessively focused on a few things. That's all.
but
So-
when we're talking about this stuff, you understand what we're talking about, and so that's kind of a great relief and a pleasure. So
Well,
thank
no,
you.
I appreciate that. One of the things you're going to find is the members of our outdoor lighting code committee who are not as technically trained still they've invested. They're all volunteers, and they are willing to struggle through our explanations, and we have to try to avoid things like nits and explain what surface brightness means, right? Yeah, if we
Yeah.
do that, they are very helpful in helping us then make the next leap, which is to the general public, right?
Yeah, people glaze over when you try to explain luminance and
That's right.
things using the metrics. The metrics are too difficult. I don't.
They are hard.
By the way, is the dog healthy?
The dog is great. Yeah, the dog
I
is
don't have a
healthy.
dog slide like that. It's
Yeah.
it's
I-
really hard to discuss luminance and the measurements and to have people understand how these things interrelate.
Well, that's
So-
why I
so
think that's why
Just to
that's why I-
interject real
yeah.
quickly, Bill, I just wanted to also note that this whole meeting has been recorded. So with your
Mhm.
permission, we can actually post this video. And then, that would help other members of the committee and other folks
Yeah.
come up to speed on this discussion, but it's
As
based
long
on
as
your
it
I
didn't
permission.
hope
say
I
any-
didn't say anything.
you say any bad
really
words,
stupid,
I hope
so-
not.
Sure. Yeah. No,
Buell, I
I
would,
know
I
you're
would
you're safe
also,
there. No, that's fine.
I would,
The goal here is everybody has the same goal. And so it looks like we're in trouble now, or someone's calling me, or calling you. I don't know what that is.
I'm okay.
so Buell, I was going to add that Dan and Clayton have done a really good job at putting a real parade of people in front of us. And we've heard from a lot of stakeholders and have gotten a lot of good feedback. And while maybe there were different interests presented to us, I think, so far we haven't really heard anything that has sort of concerned us that we won't be able to come up with something that everybody thinks will be better at the end of the day. So we haven't really, we think that, with all the good research that's been done out there, that we'll have a very, I think, good basis on which to make a presentation to people that I think everybody will feel that it's been it's a healthy advance on this, and they'll get what they're looking for. I mean, and we can get a good code out of this.
Not sure. It looks like Buell might have
Things
frozen.
might have froze. Yeah.
So with that, I'm going to go ahead and stop the recording. And also, oh, Buell's back.
Yeah, sorry. Somehow I got kicked out.
No problem.
Anyway, no, I don't mind the recording. I think next week's meeting, maybe we'll just be able to finalize the questions, I guess, and clarify what the questions are. That would be useful. If
Okay.